Hi everyone, this is a review for a quiz that we're taking this week. It is 2.1 to 2.3, so let's get started. This goes over the review worksheet that you have. The first question says determine whether the equation defines y as a function of x. They're asking you is this a function. So the first question, here it goes y equals x cubed. What this is looking like here, y equals x cubed, this is a graph with your right arm up. So it looks like this point from 0, this is going to go up, this is going to go down. And what you're looking at is one value. For every x value, you have one y value. So another way of thinking of it is if I were to graph this, like x here and then y, and I plugged in points like -1, 0, 1, 2, etc. If I plug in -1, it would be -1 to the third power. So that's negative times negative times negative, which is -1. So -1, -1. If I plug 0, that's 0 to the third power, which is 0, 0, 0. 1, so 1 to the third power is still 1, so 1, 1. And then 2 to the third power is 8, so 2, 8. Basically what that's saying is for every one value of x, you have one value of y. So yes, this is a function. Additionally, it does pass my vertical line test, meaning I could draw a straight line through any part of this graph, and it would only intersect at one place because for every value of x, you have only one value of y. So yes, this would be a function. For this problem here, the key to these problems, if you see this kind of question where it defines y as a function of x, is to solve for y. So this one was already solved for y. So for this problem, I'm going to solve for y. I get y squared is equal to -x plus 1. I'm going to move that x to the other side. And then I'm going to square root both sides. And when I do that, I get y is equal to plus or minus the square root of -x plus 1. What this does is this is not a function. And the reason for this is that, I mean, we can definitely plug values in. So let's do that. Let's just plug values in. Most people don't know what this looks like. So let's see what happens. If we plug in 0, the opposite of 0 is still 0. 0 plus 1 is 1, square root of 1, 1, and -1. If I plugged in, let's see, so 0, -1, positive. What if I plugged in, let's see, what if I plugged in, this is plus or -1. It's got to be a positive number for sure. So let's think of -3. So if I plugged in -3, I get the opposite of -3. Add 1. So the opposite of -3 is 3. So 3 plus 1 is 4. And then the square root of 4 would be plus or minus 2. So just with those 2 points, what would this look like? This would look like a graph like this. We have 0 plus or minus 1, and we have -3 plus or minus 2. And so it kind of looks like it does something like this, probably like that, right? Okay, so why do I think it looks like this? Let me tell you why. Most of the time, okay, so when you're graphing a square root, okay, if you had y equals x squared, that's a parabola, right? And that's going to go like this. But if you have x is equal to y squared, right, and you were graphing that, you're going to solve for y. You're going to get y is equal to the square root of x. Well, the square root of x is going to look like a graph that generally is a sideways parabola instead of like this. And for every value that you plug in here, you get two answers. You get a plus or you get a minus, okay? Now, and so you get, like if I plugged in 4, x is 4, so then I'm going to get 2 and -2. Definitely see that does not pass the straight line test. These are not functions, but square root of x looks like this. But what if I had y equals the opposite of the square root of x? Well, what that does, if the negative's outside, is it reflects it across the x-axis. So basically, if I were to reflect this across the x-axis, sort of like spin it around, I get the same graph. But if I said y is equal to the square root of -x, like in here, see how that's -x? The -x, what that does is it reflects it across the y-axis. So my graph now would actually go to the left like this, okay? Now, why does it look like the points out here? The reason for that is if I were to factor out, let's say, a negative sign. Now, you can't factor it out of the root, but if you factored it out of, moved it away from the x, so like you would get negative quantity x minus 1. You see that? And what happens here is that moves the graph. It's still under the root. The negative sign is still under the root, so it is a reflection across y. But this negative 1 here moves it to the right 1 unit. And so that is why that's there. Okay, not a function. Given the function, evaluate the following. So what they want you to do here is to plug these values here inside and make it, see what happens. So we're going to plug in x minus 1. So we do that, we get the quantity, x minus 1 to the third power, see right here? And then over x minus 1, that's where wherever I see an x, I'm going to put x minus 1 instead. So here I had the x, and now I'm going to put x minus 1. Here down at the bottom, in the denominator, I have x. I'm going to change it with x minus 1. But don't forget, you still have plus 1 there. So in simplifying, you get f of x minus 1, and then that's going to equal x minus 1, quantity cubed, all over x, because the 1's are going to cancel. And we're going to leave it just like this. You may not cancel anything on this, just leave it. For the 1/4, for this one, I'm going to take 1/4 and put it in wherever I see an x. So on top, on the numerator, I see 1/4. That's to the third power. And on the denominator, I have 1/4, see right here, for this part, and then add 1. Now, I'm going to multiply this by 4 over 4, okay, so I can combine those two terms. So on the numerator, I have 1/4 times 1/4 times 1/4, which is 1 over 64. On the denominator, I have this common denominator, the common denominator is 4. And so 4. So that's 1 plus 4, which is 5. So that's 5/4. So I have 1 over 64 divided by 5 over 64. So that's 1 over 64 times the reciprocal, which is 4 over 5. 4 divides into 64 16 times. 16 times 5 is 80, so this is 1 over 80, and there's the answer. For this problem, I'm gonna plug in 3x squared into x. So we've got parentheses, 3x squared, and then that's going to be to the third power, all over 3x squared, and then add 1. All they're asking me to do is to plug these in. They're not asking me for the domain or the range or anything like that. Just plug the values in. So we did. Except for this top part, I can simplify a little bit, and meaning that's 3x squared times 3x squared times 3x squared. Most kids will get this part right, where it's x to the 6th power, because that's, you have to multiply those, but a lot will forget that the 3 is to the 1 power, and that 3 has to be multiplied by 1. So that's 3 to the 3rd power, which is 27. And so this is all over 3x squared, add 1. And do not, this is a quantity, do not break into that. That is your answer. Just leave it like that. The next set of problems are asking for the actual domain. So when you see x squared plus 2, you know that's a parabola. Okay, and when it's a parabola, parabolas are going to, if it's just y equals x squared, the x squared would look like this, right? Y equals x squared. However, because it's a plus 2, what that did was it moved it up 2 units, right? So that's all it did. But regardless, if you moved it up or move it down, flip it upside down, you're still going to have the same domain. Domain goes left to right, low to high, okay? It's as if you're walking this way, right? You're walk this way. And so this is going to go from negative infinity all the way to infinity. And these values are, it's like, how can I describe it? It's like a magnet, like a magnetic field, okay? So these points here on the left, these are going to come down to the x-axis. But every time you think you've come to the end, they're just going to keep going, okay? Likewise on the right, it's like comes down, comes down, comes down. And so when are they going to end? They're never going to end. So the way you would write it, and they ask you to put it in any notation, there's 2 notations you can use. You can use the set notation, or you could just say x is an element of all real numbers because it goes left to right, all values. Or my personal favorite is negative infinity to infinity, because that encompasses everything. And you have to use parentheses with infinity. For this problem here, this problem is saying, hey, what can x not, when you have a variable on the denominator, you may not have that equal to 0. Otherwise, the value is undefined. So basically, you're asking yourself, when is that denominator going to be 0? I don't want that. So you've got x squared minus 4 cannot be 0, cannot be 0. And so therefore, if it can't be 0, when I move and I solve for 0, I solve for x, and I move the 4 to the other side, I get x squared equals 4. I square root both sides, I get x equals plus or minus 2. All right? That means it cannot equal those values. So there's no value there, meaning there's an actual asymptote there. It's like a value that you can't touch. You can get very, very close to it, but you can't touch it. So I would think that for this problem, you would write this as set notation. You would say solution set, you would say x, for every value of x, x cannot equal 2 or negative 2. So you can get away with plus or minus 2 and graph that and do that. Now, the other option for that is to actually say, let's see if I can move this. I'm going to move this over here. It can't be 2 or negative 2. So realistically, this is what we're looking at. Here's negative 2. Here's 2. It can't be this value or it can't be this value. There's holes there, but it can be all the values going that way. It can be all the values in here, and it can be all the values on the right. Meaning it could be, so this is interval notation. It could be, let me put it up here, negative infinity to negative 2, parenthesis, because it can't include, that's a hole, union, and all this values in between, which is negative 2 to 2, and also the values forever this way. And so, I ran out of room. Let me move this up. And so, union with positive 2, and then it's going to go on to infinity. So if you were going to write this in interval notation, you would write it this way, okay? This is set notation here, this stuff. On the top, this is interval notation. For these problems like this that are under the root, those ones, they cannot equal, or they can't equal a negative number. They have to be positive, but they can be 0. So in that case, you would make this inside value here greater than or equal to 0. So you would say 3x minus 12 is greater than or equal to 0. 3x is greater than or equal to 12, so x is greater than or equal to 4. So what that actually looks like is, here's 4, okay? Greater than or equal to, so it can equal 4, but it's going to be greater than that. So it's all the values from 4 on. So if you said interval notation, you would write bracket 4 all the way to infinity, and that would be parentheses. Parentheses are always around infinity. Or if you did set notation, you would write this as solution set. You'd say for all values of x, x has to be greater than or equal to 4. And this is also completely fine to write it like that. Now, lastly, you have this section, this problem, and this problem has an issue on the denominator because it can't be here. See how we said greater than or equal to 0? This one has to be just greater than 0, because if it was 0, you would have an undefined value. And I remember, thanks James for pointing that out and reminding me of that in class. But this has to be just greater than 0. So meaning you have 3x plus 1 is greater than 0. So you'd have to say 3x is greater than negative 1, x is greater than negative 1/3. So again, here's my little set graph, my little graph, and this is negative 1/3. So x has to be greater than that. So this is an open circle going to the right. And so that's graphing it. If I want to put this in interval notation, I would say parenthesis, negative 1/3 to infinity. If I wanted to put this in set notation, I would say solution set. I don't know if you could see that with the thing in the corner, so I'm going to move this up. I would say, here it up here, for all values of x, x has to be greater than negative 1/3, and then you would close that up. For these problems here, we're trying to plug the values in and find the domain. So for this first one, f minus g of x, all that's saying is find f of x, subtract g of x. So you're going to subtract them. So f of x was this part right here. So it's going to be x squared add 2x. And then I'm going to subtract g of x. Now this is g of x, but g of x is a quantity. It has two terms in it. So when you subtract that, you absolutely need to make sure that you are subtracting the quantity. 3x squared subtract 1. So we have x squared plus 2x. I'm going to subtract 3x squared and minus negative, which is plus 1. So my final answer here would be 1 minus 3, which is negative 2x squared. Plus 2x and add 1. So this again is a quadratic because it's an x squared graph, and it is a parabola that is reflected across the x-axis, right? Meaning I do know it goes through 1. I don't know if it actually goes through 1 like this or if it goes through 1 over here. And realistically, it doesn't even matter right now because what they're asking me is what's the domain. And the domain is all the values from left to right. And what that means is in this kind of problem for parabolas, the domain is always going to be all real numbers. So you would say negative infinity to infinity, or you could say x is an element of all real numbers. Okay? For this problem, it says f of x over h of x. And what does that mean? That means f of x, take your f of x equation and put it over h of x, okay? And so here's h of x. And so f of x is this. So you're going to have x squared plus 2x over h of x, which is this. And that is, what is that? The square root of 3x minus 6. Well, remember, if you have a root on the denominator, then you're going to set this inside greater than 0. Okay, thanks, James. So we have 3x is greater than 6. X is greater than 2. So realistically, we can say that the domain is going to be, for all values of x, x must be greater than 2. All right. However, one thing is, I didn't answer the question. Let me move that up here. Excuse me. This right here, this and this, oops, hello. That right there, that goes here. So you're going to say x squared plus 2x. I could factor out an x, and that would be x plus 2, but it's all over this root, which is 3x minus 6. And you can't factor out you can factor out a 3 on the denominator, but realistically, it's not gonna matter, because think about this. If I had x minus 2, right, I'm still gonna set that greater than 0, and 3 is greater than 0, but x minus 2 is greater than 0. So you just have to basically set them both. You're gonna get the same answer there. This slide is asking you whether or not these are functions. Do these pass my vertical line test? So this is yes, totally, function. Now this one, a lot of kids get tricked. This one they're like, I don't know. I'm very hesitant. This is a function because I can go anywhere through here and it will pass my straight line test. Now this is where it gets a little weird because you have a solid circle, right? And then you have the open circle. That goes with this. Well, here's the thing. If you draw a vertical line test, how many points does it intersect? Just one. Because it's like this solid circle is like rock, paper, scissors, right? Covering it. This covers this. But if, in fact, this was solid and this was solid, that would not be a function because then I'd have two values of y for one value of x. Can't have that. And then this one, we've already done this, right? This is y squared. So I just like to write this on this side. So y squared equals x. Square root both sides, right? You get y is equal to the square root of x. Well, we already know that this graph technically looks like this. Is not a function because for every value of x, I'm going to get plus or minus values of x. If I plug in 4, the square root of 4 is plus or minus 2. So if I go over 1, 2, 3, 4, I'm going to get positive 2, and I'm going to get negative 2, and not a function. And what that means really is that if you were to draw that on your or like type that in your calculator and like, no, it's a function. Well, what you're seeing is just this, right? If you type that in, because this is what your calculator will do. It'll just give you that one part, because as soon as you turn this corner this way, it's not a function. And your calculator will only graph functions. So as soon as this turns the corner and gets positive or negative values, right? You plug in 1. What's the square root of 1? 1 or negative 1. There's 2 answers. But your calculator won't graph 2 answers because it only graphs functions. For these problems here, your job is to figure out where it is increasing, decreasing, or constant. For me, it's again left to right, okay? So this is you, and you're like, it's like you're walking along, whoops, not that way, whoops, and here's you, and you're like walking left to right, okay? So everything you see is going left to right. And I like to say that because a lot of times you'll see an arrow going this way. That is not increasing. You have to establish yourself, and by the way, that's not there, but you have to think, what is happening as I move from left to right? Well, as I go from left to right, this is decreasing, okay? This, see, left to right is increasing. I like to put a value there. Left to right. This is decreasing, and this is increasing. So you're going to say, this is decreasing, and it's decreasing, and note to self, you are only using your x coordinates. Okay, so only x coordinates or values of x, okay, can be used here. And these are over an open interval, meaning you're not going to have any brackets, interval, okay, on increasing and decreasing. So where is it increasing? Here. So it's going from -1 to 0 and comma. You separate these by a comma, not a union, okay? -1 to 0 and parenthesis 1 to 3, 1 to 3, okay? It's decreasing from here, which is -3, so parenthesis -3 to here, -1, comma, and it's decreasing here, where am I? I'm at 0, to here, where am I? 1, so 0 to 1. Remember, you're always on the x-axis. You're just like walking along on the x-axis, okay? On this problem, the next one, number 7, says find the absolute maximum and minimum. This does not have an absolute maximum because this is going to keep going up forever. So for this problem, there's no absolute maximum. You can write NA, you can write no solution, you can write no absolute maximum. But it does have an absolute minimum, and that's going to be at 0, 0. That's your value. That's the lowest possible value. Now, the local maximum, or some people will call it a relative local maximum and a relative minimum. So my relative maximum is where it goes down after it hits top. So that's going to be at -1, 1. And at, where else am I? I am, where am I at? Local maximum. Sorry about that. 2, 3. 2, 3. Now, a local minimum would be at, even though this is my my absolute minimum, it's also a local minimum. So that's also 0, 0, and 3, 2. So 3, 2. Okay? Yeah, they can both be the same value. Now this, you're going to get a graph of a picture, some sort of picture. Note that, and I'm going to open these up just because they're a little bit tricky to see. That's open, this is solid, and this is open, okay? So what you're looking at is they're going to ask you lots of questions. They're going to say, hey, what's f of 0? Where is x? This is x inside here. The whole value is y, but the inside value is x. So where is x 0? What's happening at 0? 0 is at 0. So this is 0, 0, okay? It's not 0, 4 because there's no value there. It's an open circle. Okay, see that? That was open and that's open. They're both open. Open, open, okay? f of 4, what's happening at x is 4? Well, we are here at 4. So 4, 4. Next question is going to ask me, well, what if y is 5? Now, for me, personally, I'm looking at 5. This is what, 6? So there's 5. What are all my values that are 5, where y equals 5? That's y. This is y equals 5. This is what that line looks like, okay? And this is what this says. This whole value is y. So what's x? Well, x could be at -1, and x could also be at, here, where am I? 5, 5, 5, okay. All right. Find the domain. Well, the domain, again, goes left to right. But you have to remember that as we find the domain, it's like this magnetic pole that's pulling all these points to the x-axis, okay? So all these points here are coming up. They're coming up. These are coming down, all right? These are coming down. These are coming down, 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 like that, okay? I'm going to move my y equals 5 graph off there. So all of these points are on the top are coming down. All the points on the bottom are coming up forever. See the arrow here? That's always forever. So this here, because that's going on forever, is actually going to be, from my domain, -infinity to, this covers this, but it's open. So the salt, it's like rock, paper, scissors. The paper is going to cover the rock. It's going to close it. It's going to be full. This also is going to close that. It's going to cover it. And there we go. Every value, because there's an arrow here. So this is going to go all the way to infinity. Now my range, unlike the domain, which goes to x, my range is kind of going to squish to y. And so all these values are going to squish to y instead of x, okay? And what that's going to look like is all these values here. See, this arrow is going to keep going on forever. These are going to come this way, all over here. And because this is going to go on forever and ever, they're going to cover up any holes all the way. So that's going to be all the way from, we're going to call that a union, and that's including 0. So that actually is a bracket of 0 all the way to infinity. And remember, infinity is always parenthesis. And then what else is happening on the left is just this. If this squished all the way to the y-axis, this is just -2. So it's -2 and 0 to infinity. Now, I'm going to erase some of this so we can see what is happening for my intervals that are increasing. So again, I like to label it. So I'm going to call this, this is constant. This is, remember, left to right. So this is decreasing, and this is left to right. This is increasing. So where is the interval it's increasing? Remember, also x values. Starting at 0, and that's going to infinity. Decreasing is here. Where am I? I'm at -3, all the way to 0. And it's constant from -infinity to 3, -3, okay, parentheses. Now, the last part is asking me for the average rate of change, which, by the way, is my slope. And so you have two options, all right? Option 1 is basically, well, you can count. And option 2 is to use the slope formula, right? Which is the change in y over the change in x. Well, -4, so they're saying, hey, what's happening at -4? Well, -4, I'm down here at -2. So at -4, I'm at -2. Then the other value, and it's inclusive, so the other value from this point here all the way to 2, what's happening at 2? Here I am. Where am I? 2, 2. So I'm at 2, 2. So they're actually asking me, what is the slope of this line right here, from here to here? Well, I mean, if I just use my slope formula and I subtract my y's over subtract my x's, I'm gonna start here at this point, and I'm gonna go right minus left. So I'm gonna go 2 minus this value of y, -2, and then I'm gonna go this 2 for x minus -4. And I'm going to get 2 minus -2, which is positive 4 over 2 plus 4, which is 6. 4 over 6, which is 2/3 if I reduce. So my slope is 2/3. Now, that's one way to solve it, and that's probably the most common, maybe. Or count. just count, rise over run, right? So I'm starting at -2. Here's my rise, and here's my run, up 4 over 6. So 4 over 6, which again is 2/3. And that's the average rate of change, which again is your slope, okay? Okay, here we go. Oh, uh-oh. All right, last 2 slides. Given the function here, it's an x squared term. Remember, this is a parabola. And I know it's a parabola, and it does go through -1. At some point, it's positive. So it kind of looks like this, or it looks on the other side. I don't know which one it looks like. All I want to know is this point on that graph? Well, in order to find out if the point is on the graph, you're going to plug in the x value. This is x, this is your y value, okay? If I plug in my x value, I should get my y value if it's on there. If it's not on there, then it's not a point on the graph. So we're going to go f of -2. That's what it looks like when you plug in a value. 5 times -2 quantity squared plus 2 times -2, subtract 1. Do exponents first, so that's 4 times 5, which is 20, minus 4, which is 16. 16 minus 1, what's 16 minus 1? 15. So I get 15 when I plug in -2. So this is a point, -2, 15, which is not -2, 4. So is this point on the graph? No, it isn't. And actually the point -2, 15 is, so that brings me to believe that my graph actually looks more something like this, right? If it probably comes up like this, like that. So -2, 15, that kind of looks like that. Okay, second, I have to find the average rate of change. They want to know what is the slope from -3 to 1. Okay, well, there's a slope formula that you can use, and that is to find the slope, you're going to do, okay, we're going to subtract our y's over subtract our x's. I like to use letters for these. So I'm going to call this A, I'm going to call this B, okay? That's my -3 to 1. So if I were to subtract, I like to go also right minus left. So B minus A. And then on the top, in the numerator, I'm going to say f of B minus f of A. And the reason why I'm using f of B and f of A is because this f of, right, is y. And this is saying subtract your y's over, right? This is saying subtract your y's over subtract your x's. That's what it's saying. So as I subtract my y's, okay, so on the denominator, I'm going to do that first because that actually helps me a little bit. B minus A, so 1 minus -3. That's how I do that. 1 minus -3. So now that I have 1 minus -3, I'm going to plug in f of B. B is 1. See that? So I'm going to plug in f of 1, and then I'm going to subtract f of -3. So before I go any further, I need those values, right? So I'm going to go, okay, 1 plus 3 is 4. There's that. But now I have to find f of 1. So if I plug in f of 1, what am I going to get? Let's see. 5 times 1 squared plus 2 times 1 minus 1. What is that? 5 plus 2, 7. 7 minus 1, 6. So I've got 6. F of 1 is 6. Minus. Now I got to plug in f of -3. So 5 times -3 squared plus 2 times -3, subtract 1. So 9 times 5, what's that? 45, subtract 6, 39. 39 minus 1 is 38. So f of 3 is 38. So 6 minus 38 is -32 over 4, which is -8. So, or -8 over 1. So the average rate of change, right, or my slope is -8. Cool. All right. And I know I just wanted to put that was 6 here, and then this we said was 38. Okay. The last question that you will see, or the last type of question you're going to see on the test, or sorry, not a test, it's a quiz, is this kind of problem. They're going to give you an equation. Oh, look, it is a parabola again. And so what they're asking you to do is this. If I were to graph this parabola, and it's got to go through 6, right? I'm not sure what it looks like, but I know it goes through 6 because of the plus 6. That's my y-intercept, so it has to go through 6. Now, what they're asking me to do is, I'm just going to graph like maybe a sketch of it. I'm not sure really what it looks like, but I think it might look like something like this. I'm not really sure, but I mean, it's either going to be on that side realistically, right? Or it's going to be on this side, right? It's going to be there or there. I don't know which way it is, but it's one or the other. But what they are asking me is to find the equation. They're asking me to find the equation, not just the slope. We have to use the slope to find the equation, but not just the slope. They want the equation of the secant line. So I'm looking at my parabola. I'm like, where's my secant line? Where'd that go? Well, look at this. They want to know from -1. So here's -1, okay? So at -1, where are we? We're up here, right? And to 2, see that? -1 to 2. So 1, 2, let's say 2. Let's say 2 is here. To here. So they're actually looking for the secant line that goes through here. All right? It's like a piercing, right? It's a secant line. Let's see if I can move that a little bit. So see this line right here? It's like going through both of those points. And so they want to know, what is that equation from -1 to 2? All right? So, well, I mean, we know we're going to find the 2 points. Well, actually, at -1, I got to figure out where am I. So I've got -1 something. And here I've got 2 comma something. So remember, the first thing we're going to do is find the slope, right? The slope is going to be subtract my y's, right? Change in y over the change in x. Well, if I were to subtract my x's, and I like to go right minus left, I'm going to go 2 minus -1, okay? Now on the top, on the numerator, right, I'm going to go right minus left, which is basically f of -4 subtract f of -3. But I don't know what those values are. I actually have to plug them into my equation. So let's find f of -4. So I'm going to plug in -4. So plugging in -4, I'm going to go 2 times -4 squared, subtract 3, times -4, add 6. So we get what? 16 times 2 is 32, add 12. So that, let's see here, 32 add 12 is 44, plus 6, 50, right? 50. So f of -4 is 50, okay? So there's 50, all right? And then here for -3, so f of -3 is going to be 2 times -3 squared minus 3 times -3, add 6. So 9 times 2 is 18 plus 9, 27, add 6, 33. Okay, so 50 and then subtract 33. Okay, so it looks like my slope is 50 minus 33, which is 17. So my slope is equal to 17 over 2 plus 3, so 17 thirds. All right, so once I have my slope, it's pretty easy to find my equation because I have both points, right? When I plugged in -4, see that was right here. Do you see that? That was the point 2 comma, I had 50. I got 50. The other point on this side was what? -1 comma, and when I plugged in -3, I got 33. So you have the option of using the left side or the right side. So if I use the left side, I would go, you remember point slope form? Because I have the slope right there, and I got a point. So pick one point. So we're going to go y minus 33 is equal to 17 over 3 times the quantity x plus 1, opposite, opposite. So this is point slope form, or big or, because I can use the other point, or the other point instead. I could go y minus 50 is equal to 17 over 3 times x minus 2. And for sure, I am not requiring you to do both. You're going to do one. But because they both are going to yield the same answer. I mean, realistically, if you want to check your work, you could do both. Anyway, let's see what we have here. On the left side, we're going to go y equals, I'm going to distribute here, and then move the 33 over. So I'm going to get 17 thirds x plus 17 thirds, and then add 33. So I need a common denominator, which is going to be 3. So that's what, 99? So I've got y equals 17 thirds x, and I've got 99 plus 17. What is that? 6, 9, 10, 11, 116. So 116 over 3. So this right here would be my equation in not point slope, no, slope intercept form. So this is slope intercept form. And this form was what we called point slope form, but I'm probably going to ask you in slope intercept form because I want you to solve for y. All right. That's it. That's the quiz. So I wish you the best of luck on the quiz. I hope this helped you. And yeah, like it if you like it. That always makes me feel good. Okay, thanks for watching, and I will see you next time.